In today's lesson, we'll be learning how to solve a quadratic relation. In the image below, you'll see a basketball player shooting a basketball from the free throw line. I want to know when this ball has a height of 3 meters above the ground. The basketball has a height of 3 meters right over here and also right over here. The basketball has a height of 3 meters when it is 1 meter away from the player, and it has a height of 3 meters when it is about 3.4 meters away from the player. Therefore, when the ball has a height of 3 meters, it's both 1 meter and 3.4 meters from the player. This equation represents the basketball shooting a basketball from the free throw line. It happens to be in vertex form. If you were to evaluate this equation, the first thing you would do is look at the brackets. Within the brackets, you have the operation subtract 2.2. So the first thing you would do according to BEDMAS is subtract 2.2. Next, you would raise that to an exponent of 2. Afterwards, you would multiply by negative 0.3. And lastly, you would add 3.4. You would follow these operations in this order if you wanted to solve for y. However, if you wanted to solve for x, in other words, if you wanted to isolate x, you would have to do these operations the opposite way in the opposite direction, which means you would actually subtract 3.4 first, since that is the opposite of plus 3.4. You would then divide by negative 0.3, since that is the opposite of multiply by negative 0.3. You would square root, since square root is the opposite of squaring something, and then you would add 2.2, since that is the opposite of subtracting 2.2. That brings us back to the question, how far away is the ball from the player when it has a height of 3 meters? We already determined the answers to this graphically, but we need to do this algebraically now. Since 3 meters is a height, and the variable of y represents height, we are going to replace the variable of y with the number 3. Since I want to find the distance of the ball from the player, that means I'm actually solving for x. In other words, I want to isolate x. According to our instructions, we are going to subtract 3.4 from both sides of the equation. That means these values are going to cancel out. And 3 subtract 3.4 becomes negative 0.4. Our next step is to divide both sides of the equation by negative 0.3. These values are going to cancel out, and negative 0.4 divided by negative 0.3 becomes 1.33. Next, we want to square root both sides of the equation. The square root and the square are going to cancel out. And the square root of 1.33 is plus or minus 1.15. And that is because when you square root a number, it gives both a positive and negative answer. Our next step is to add 2.2 to both sides of the equation. This and this cancel out. We now have two paths to take. Positive 1.15 plus 2.2 and negative 1.15 plus 2.2. This means our basketball will have a height of 3 meters when it is both 3.35 meters away from the player and when it is about 1.05 meters away from the player. You'll recall that these values match the ones we found graphically earlier.